The Earth, our home, is not just a surface we see and live on every day. It is much more complex, with layers hidden beneath its surface, each with its own unique characteristics and functions. Earth's layer can be assigned according to chemical composition or mechanical properties. Earth is composed of four main layers based on chemical composition, starting with an inner core at the planet's center enveloped by the outer core, mantle, and the crust. Our journey begins with the crust, the thin layer where we live. It is the outermost shell of our planet that covers the Earth's mantle. The crust is composed of various rocks, minerals, and elements, which gives it a diverse and intriguing nature. Crust is brittle in nature. During earthquake, the crust breaks easily, causing a fault. The Earth's crust can be divided into two major types, the continental crust and the oceanic crust. The continental crust is found beneath the continents and is generally thicker and less dense compared to the oceanic crust, which underlines the ocean basins. The continental crust is primarily composed of granite, light-colored igneous rocks rich in minerals like quartz and feldspar. In contrast, the oceanic crust is mainly made up of basalt, a dark-colored igneous rock that is denser and contains more iron and magnesium. The thickness of the crust varies according to oceanic and continental areas. Ocean is like a cavity filled with water. So obviously, the thickness of the oceanic crust is less compared to the continental crust. The thickness of the continental crust is about 35 kilometers, whereas the oceanic is about 5 to 10 kilometers in depth. We all know about the Mariana Trench in the Western Pacific Ocean, right? It is the deepest part of world's ocean with a staggering depth of about 11,000 meters. That is 11 kilometers below sea level. Beneath the crust lies the mantle, stretching about 2,900 kilometers deep. It is divided into upper and lower mantle. The upper mantle is also known as asthenosphere, and lower mantle is also known as mesospheric mantle. The upper mantle, along with the crust, forms the lithosphere, the tectonic plate that shape our world's geography. The total thickness of the crust and the upper mantle, which is also known as lithosphere, is about 250 kilometers. The mantle is mainly composed of ferromagnesium silicates. It's not a pool of molten lava as often depicted, but primarily solid rock heated to temperatures between 500 to 900 Celsius near the crust and up to 4000 degrees Celsius near the core. However, it's important to note that these temperatures can vary based on locations and depth. The rock in the mantle is subject to extreme temperature and pressures, which can cause it to behave like a very slow-moving liquid over a long period of time. Movement within the mantle due to heat from the Earth's core and the decay of radioactive elements creates convection currents. These convection currents are the key drivers of the tectonic plate movements at the Earth's surface, leading to phenomena like earthquake and volcanic eruption. Continuing our journey inward, we reach the core, which is divided into two parts, the outer core and the inner core. The outer core is a sea of molten iron and nickel with traces of other lighter elements. The outer core is approximately 2,600 kilometers thick. Then we reach our journey's final destination, the inner core, a solid ball of iron and nickel with temperatures reaching up to 5,700 degrees Celsius, which is hotter than the surface of the sun. It's about 1,200 kilometers in diameter, roughly the size of the moon. These temperatures are estimated based on experimental and computational models, as it's currently impossible to measure them directly. There is still much to learn about the inner core, and ongoing research continues to uncover more about our planet's intriguing center. And so, our journey ends at the heart of the Earth, a testament to the astounding complexity and wonder of the world beneath our feet. This is the interior of the Earth, a marvel of nature, a testament of the forces that shape our planet and our home.